Hi, everyone. Welcome to the session on Container First Microservices Strategy. My name is Sridhar Prabhakar. I'm a senior technical consultant at Aspire Systems. And let's look at the agenda for today quickly. So, as you see on the screen, today's agenda will be to give you a quick introduction of us, me, and the company, Aspire Systems. And secondly, we'll look at get a quick introduction of containers, microservices, other frameworks, and the ideas that are behind it. Uh, After that, we look at the various deployment strategies for containers, how to do container orchestration, and a few others. And we'll also look at tools and services that are commonly used today. And finally, we look at some of the case studies that we as a company have done, we as a company have experienced with our clients. Right. Going forward, let's start with about Aspire. Aspire is a services company with our core DNA as software engineering. We started our operations, we started the company with the idea of serving product companies. So we used to call it product engineering. We are more than 3,000 employees strong with more than 150 customers across the globe. Uh, our our vertical focus, though limited, is on ISVs or independent software vendors, retail and distribution and consumer products. We also have banking and financial services as a separate vertical. Uh, with respect to certification, we are CMMI maturity level 3 certified, and also ISO 9001 2015 and ISO 27001 2013 certified. We have a lot of expertise in software engineering, digital services, testing, and infrastructure management and application support. As to the locations, we are headquartered in Singapore, but we are present across the globe. We have offices in US, UK, Benelux area, Middle East, and India, with India being our major development center. And as you can see in the last point, we have been recognized as the best place to work for 10 consecutive times by the Great Places to Work Institute. And as to the certifications and awards, you can see at the bottom, we have quite a few awards and accolades. And now moving down to our DevOps practice, as part of Aspire, I also head the DevOps practice within the company. So this group, this subgroup within Aspire Systems, has about 50 active consultants and engineers who are trained in DevOps tools and practices and in a variety of things. Uh, we have executed over 100 projects in the last year, and we currently have 25 active customers. Uh, and as you can see, there are quite a few logos of our prominent clients. Uh, KPMG, Pearson, Guidewire, Temenos. So yeah, we worked across or on different business domains. We've been able to work with all of them from a agnostic DevOps standpoint. And we're also AWS partners. We're also Gold Microsoft partners. We do a lot of work on Azure and AWS. Moving forward, just to quickly recap on what Aspire does, we are strong in the areas that are listed here. We have cloud and infra automation groups, which specialize in cloud and infra automation. We write Ansible scripts, we write Puppet, Chef scripts. We help you automate your infrastructure provisioning and deployment. Similarly, we have a lot of engineers who are trained with building CI/CD pipelines on Jenkins, Bamboo, Azure DevOps, or AWS Code Build, or whatever it is. Right? We have expertise in a variety of tools, and we've helped a lot of customers build their CI/CD pipelines. Similarly, another trend that we see is some customers have been able to productize their CI/CD pipelines, wherein their internal CI/CD pipelines are sold to their own customers with a bit of a generalization and a bit of a dashboard in front of it. Right. So we've been able to do that for a few customers, and that's one of our specialties. Uh, we also do a lot of hybrid deployments with deployments spread into multiple clouds, some parts of it being on-prem and all of that. And another area of expertise is microservices deployment. We do a lot of microservices deployment using containers or app services or whatever it is that some providers give. So it can be container based. Again, it can be cloud managed, or it can be self-managed services or self-managed frameworks and tools. Similarly, we have a special group called Cloud Ops that specializes in cloud migration and consulting. Uh, and also we help with database and queue deployments and any other custom DevOps solutions in portals. Now, moving on to the second part of our session, let's also look at a typical comparison of uh, the different architectural patterns or the evolution of the architectural pattern. Right? Typically, back then we wrote monolithic applications where applications are typically built as a single component. Everything is in one box. Everything performed along with the other parts of it. Uh, and then we moved on to a design pattern or an architectural pattern called SOA, which is service-oriented architecture, where we tried to separate components out into smaller pieces. So there was a bit of decoupling of components, and yet for integration between them, we typically used ESBs, workflows, and other things that helped communication between these services. So the problem there, I mean, I wouldn't essentially call it a problem. There are still a lot of applications that are using SOA and all that. But in SOA, the architectural pattern relies on inter-process communication a lot. So the services typically relied on the existence of another app. So it had to be made sure that all services are up at all times. There was very little fault tolerance and all that. And that's when we realized that it had to be improved. And that's when the microservices architectural idea evolved, where every service worked as an independent unit. It did not care if another service is up and running. Things are typically passed on using an event model. So whenever a service finishes a task, it will raise an event and say done with it, and it doesn't care what happens after that. So another service can pick it up, work on it, and it can do that whenever it is available. It doesn't have to be up all the time. So the microservice architecture basically brought in that fault tolerance, and similarly, upgrades were made easy with them being on containers. The containers could rapidly be replaced and upgraded while nothing is down. While the old containers are still up, it could replace some parts of it and slowly route traffic to the new containers. So the downtime was literally reduced to zero, uh, and upgradability became very easy. It was just a matter of pushing a new image, and the orchestration layer could just pull the containers and deploy them automatically without anyone even noticing a change. Right. So those are the three design patterns, and there is also a comparative description of what these three do. With respect to cost, because everything is in a single machine, you don't know what performs how much. You typically provision or over provision infra. You have large machines that can spike up and down, handle little spikes. Uh, and again, because there was no inter-process communication, you would have lower I/O cost, network costs. Uh, Whereas in SOA, SOA is right in the middle of microservices and the monolithic architecture. Right. So they will have lower infra cost compared to monolithic apps because some parts of it can be scaled to a higher level while some parts can be scaled down and kept at a minimal level. So there is a trade-off there. You still can provision large machines for individual services, but uh, for applications that are not scaled too much, that don't go beyond 4 or 5 machines, it may not make sense. SOA will cost you more. But for large applications that have a large volume of requests, then yes, SOA, moving to SOA and then to microservices makes sense. So it is in that order that microservices will cost a lot less in terms of infrastructure because they automatically scale up and down. They keep your infrastructure scaled to the level of the demand that is out there. But of course, there's a lot of chatter between services or through events that requires a lot of network IO. So that cost will increase. Uh, with respect to scalability, uh, of course, with a monolithic architecture, there are limits to how horizontally it can scale. Similarly, since the app does everything from the same machine, there is very little scope for optimization or to improve how the application scales, right? Without touching the code. So that's the problem with monolithic architecture, and it's a relative scale from then on. SOA apps scale better, uh, of course, because each service is receiving far less load when compared to monolithic apps. Uh, so the overall load is distributed between the services, and that's how SOA achieves a little better scale. Whereas microservices, they can achieve nonlinear scaling. They can have thousands of machines per service. Each service doesn't have to go through a bottleneck or anything, right? So that way, the scalability aspect just keeps improving through the three stages. Similarly, inter-process communication, when I talked about cost, it was evident that monolithic architecture, since it talks to the same process or the same JVM or whatever it is, the inter-process communication is almost literally nil. So there is no chatter over the network. It's relatively little. Whereas with SOA, it's slightly larger, and with microservices, it's a lot of communication between services. But again, there is fault tolerance built into it. The architecture allows for some services to be down, or when they come up, it can react to something. So the communication is taken care of. So the difference there with SOA and microservices is that microservices doesn't expect the reacting service to be up all the time, whereas SOA does. Upgradability, as I told you before, monolithic services, you typically have to have a complete duplicate of your application, go for a blue-green deployment, switch over and cut over, and yet you could see a little downtime. Since you're upgrading the entire app, even though a small piece of the code is changed. So there is a lot of risk involved. And if a service is down, your entire application is down. Or if you make a mistake, the entire application is down. That is what is addressed in the subsequent architectures. SOA, you're not upgrading the entire application, you're upgrading some parts of it, or you're upgrading some services within it. But yet, that still is not entirely risk-free, because if your service is down, SOA still relies that some service needs to be up. Whereas with microservices, it's entirely handled. Even if the service is down, uh, the other services don't have to wait for it. It'll just perform its task and continue with it. So overall, from a user experience perspective, microservices would give you the best experience with even if there are faults, even if there are failures underneath, right? And with respect to code maintainability, again, monolithic applications are written as large chunks of code. Uh, Typically, they become unmanageable over time. But SOA and microservices have the same gradient of code maintainability happens here. So SOA is slightly better to maintain. Microservices are very easy to maintain because the service itself are written as separate, functionally separated, and the service doesn't rely on anything else. So the integration aspect doesn't have to be taken care of. So yeah, that's what functionally microservices are better maintainable. Likewise, let's take a look at some of the challenges or some of the strategies that you have to take care of when you're implementing a microservices strategy, right? Again, we are talking about all of this in the perspective of containers. This the whole idea of microservices is being pushed by containers because microservices requires things to be dynamic, requires things to be uh, replaced at runtime, scaled, and automatically managed. Containers are the core component in it. So that is why a container first microservice strategy makes sense. You can of course build a microservices architecture with just VMs, but it still wouldn't be as scalable as a container based architecture. So that is why we are looking at this only in the perspective of containers. With respect to how you deploy your microservices, uh, there are a couple of things that you can do. And as written here, let's not even talk about bundling multiple services in a single container. It doesn't make sense. Uh, so what we recommend is always a service should be in a container. Uh, you can have multiple containers run the same service, but not the reverse. You cannot have multiple services run on the same container. Just for operational purposes, right? If we have that deployment option, we will run into the same problem of deploying a monolithic service. So for the scope of this discussion, let's not even consider multiple services on a single container. So the other options are multiple services deployed per host. So you can have a single VM or a host with multiple containers deployed on it on different ports. That's still valid. Again, you can have multiple servers running, and you can spread your containers on different services. So the same service can run on multiple VMs uh, in a scale mode. So although it's the same service, you can spread it across multiple VMs just for it to be fault tolerant. Uh, the other option is you can have just one service per VM, one container within that VM. Of course, this looks a lot like a VM approach, but it still has its own advantages in the sense a VM, even though the VM is still running, if the service is down, it's easy for you to recover from it. You can have Kubernetes or ECS to recover a container within a VM, right? Instead of directly deploying application code on the VM, if it's containers, it's easy to recover and restore things back. So those are at the service deployment strategy. Again, we have other strategies to take care of. How do you route between how do you route traffic and how do you route traffic between services? Similarly, we'll have to look at how you store your data, how you scale your application, and how do you take care of security, right? With respect to routing strategies, you can, of course, always do direct client to microservice routing, which means you're not utilizing some of the features of a discovery service or an API gateway, uh, which is still a valid model of operation as long as your requests are scaled that way. That is, your individual services are self-managed, they scale and they perform adequately. So, for example, if you use an app service on Azure, you could always deploy a container to an app service, and Azure takes care of scaling it to whatever level. So that lets you use a client to directly access that microservice and have no intermediates in between. With that said, again, there are other strategies where you can have a discovery service in between for your clients to identify endpoints for your services. So you can have hundreds of services. Each service will register itself with a discovery service, uh, which in turn will issue a service endpoint whenever requested for. This eliminates a hassle over a load balanced architecture, right? So it doesn't have to have a single entry point. A client can get an endpoint on demand and then start using it as long as the endpoint is available. So with this idea, you can literally scale it to thousands of machines or millions of machines if you wanted to, right? So that's the advantage of using just a discovery service. But again, you're exposing the underlying components directly to clients. So special care has to be taken with respect to security on how a client or a service endpoint is protected. Right. The third option is using an API gateway where all your traffic is routed through an API gateway. The only difference between this and the previous option of using a discovery service is that your underlying service is a little protected. Everything is routed through an API gateway, wherein the API gateway uses a discovery service to identify a service endpoint and route accordingly. Uh, so having these are the three basic strategies, but other than that, we should always use a CDN for static data so that your overall traffic to your underlying services is managed and reduced. Uh, those are your typical routing strategies. You can always pick one based on how the application is built and how you want it to work. Uh, and with respect to data storage strategies, typically, we recommend our customers to use managed services because of the hassle of managing VMs and managing the software itself. So, using managed services on the cloud, so using RDS on AWS or any of these services to store data, will eliminate the need for you to have specialized skill sets, right? So, how the storage is increased, how it scales, how it geo replicates, all of that is managed by the cloud, wherein you only use an endpoint to send and get data, right? That's typically what we recommend just to get away with the hassle of managing machines. But of course, some of our clients have asked for uh, maintaining their own VMs, maintaining their own infrastructure for everything, queues, everything is deployed by themselves and managed by themselves. Uh, we have done a lot of that work, but that's also a strategy that you can use depending on the kind of data that you store. If you don't rely or if you don't want to use services that way, you can always deploy them on VMs. Uh, of course, it has its own costs. And of course, with hybrid models, there are a lot of clients who are extremely cautious about how and where they share their data. So many of them prefer on-prem data storage, and that's a perfectly valid strategy too. With respect to scaling, there is always monitored auto scaling. You can have Kubernetes, or you can use a variety of monitoring tools to monitor your infrastructure, look at the CPU performance or memory performance, uh, and decide based on certain thresholds to scale your system automatically, scale up and down, scale both ways. Uh, of course, you can always use container orchestration tools to auto scale these instances. So when you're using containers, of course, Kubernetes will let you scale more containers within your hardware. Your EC2 instances or any VMs, the number of VMs that you use in the setup can also be automatically scaled using these monitoring tools. And once the VMs are scaled, you can always use Kubernetes to deploy more containers onto these VMs and handle them. And of course, when you're scaling, you should also look at how and where you scale. We have to be a little aware of uh, our business continuity plans or recovery and backup plans, how to scale into multiple regions, how to replicate between geographic locations, and all that. Right. So those are some of the points that you have to think of when you do scaling. And finally, looking at security strategies. I mean, I wouldn't call it strategy. These are essential things that you have to do. Uh, all network-based security, all machines to be protected and exposed to what they should and what they can, right? It shouldn't do anything more than what is needed by your internal services. Similarly, patching of your VMs, isolating private services. So within your service ecosystem, some services could be private. They may not be client facing. So you can isolate them to a separate subnet and make sure that nothing uh, accesses it without actual permissions or without or from outside of that network. Similarly, routing with the proper auth filters, making sure that only people with the privilege access things, right? So at a high level, these are things that you take care of when you plan to implement a microservices architecture. These are things that you always implement and manage it from a development standpoint, from management standpoint, and at every aspect. Right. Let's look at the security operations aspect as well. This is not entirely related to microservices alone. It is a general set of operations. There's a general set of guidelines to be followed. Uh, so there are four core aspects to it. How do you protect your source code? How do you protect your artifacts? How do you protect deployments? And how do you protect your network and process? Right. And as you can see, with respect to the source code, for us, it is mandatory that we have to be careful even with developers. uh, it is quite common for even developers to make mistakes. So the threat is not just from the outside, it is also from inside. So we have to keep retention policies, make sure that who has a copy of your code. Similarly, we have to do periodic scanning, security scanning, clone scanning, see if there are copies of your code elsewhere where it's not supposed to be. Uh, Make sure that there is no sensitive information leak. Right? Similarly, branching strategy and protection. You have to make sure that your developers own particular branches and not just everything out there. To make sure that people have the right permissions and right access. We've always recommended feature-based branching, where each branch is given to a feature owner, where he can delegate that to his own team members. But again, there is control over who gets to access what. And as always, the sensitive information should always be hidden from uh, I mean, it need not be exposed to developers. Say a production key or a production credential need not be exposed to a developer. It can only be given access to one particular person, but the rest is automated. So the access setting for all of this is important. And similarly, all your unused branches need to be deleted frequently so that nothing that is old is retained and accidentally transmitted anywhere. The next part is how do you protect your artifacts? How do you make sure that say your Docker images or your binaries, how are they protected? Where are they stored? They can be stored on a local repository, or even if they are public, how do you protect them? So this whole section is about prescribing ideas on how to protect your artifacts. Who has access to it, and who can delete or who can modify things. Typically, we don't recommend that. I mean, artifacts are immutable. We don't prescribe artifacts to be deleted at any point. They can be archived but never deleted. Uh, so that's how we pitch things. Once an artifact is released or created, even if it's faulty, even if it is not a release candidate, we still have to keep a track of it just to make sure that everything is traceable, right? Uh, and the third aspect is protection of deployments, which is very straightforward. Who, how you provision environments, how you provision particular applications, how are they protected, who has access to it, what protocols are exposed from each of it. How do you approve movement of a particular deployment from one stage to another stage? Who takes care of it? Who terminates it? All of this is what is considered in protection of deployments. Uh, Similarly, the last aspect is network and process, where we have to take care of what is exposed to the outside world, how the application is protected, what are the firewall settings, how VPNs are set up, everything related to it. So how do we? So these are all things that are in the control of the DevOps team, right? It's all in. I mean, these can all be controlled through a tool or something. What is more important is a process related control where your team needs to be aware of how things are managed, how things are stored, why it is important for you to delete your local clone whenever it is needed. Uh, so it is important for you to sensitize or have teams learn about all the security guidelines, make them understand how things are, make them realize that things can potentially cause harm. Uh, Similarly, you also have to protect all your processing software like Jenkins, Bamboo, or anything that stores keys and accesses other systems in your ecosystem needs to be controlled at some point. They need to be protected, and any key that it has needs to be either encrypted or something like that to make sure that nothing is exposed from those services. So those services also need to be protected from a network standpoint. But again, those services are also required to be secure in more ways. They should not expose keys. They should not expose credentials in any way. No credential should ever be printed, and so on. And yes, all programmatic access should be handled with a separate user ID or an API key, just to track usage. And even if there is going to be a breach or something, it should be quite easy to just refresh that key and not ruin operations for a lot of it. So never ever share a user's key for a programmatic access. So so that again, that key can always be rotated. That key can always be changed randomly, just to make sure that even if there is old code distributed elsewhere, you always have a new version that makes old sensitive information obsolete, right? Moving on, again, I'd like to introduce you to tools that we commonly use and prescribe to our own clients for deploying microservices on the cloud or even on prem. So typically for orchestration or building a CI/CD environment, we've done work on Azure DevOps, AWS tools suites, Jenkins and Bamboo, and I would say that there is no winner here. Everything has their own strengths and weaknesses. Uh, Jenkins is free. It's the most versatile tool, but of course it requires a lot of programming to be done. Whereas the other tools are a little more extensive in their features, and they can offer a lot more out of the box. So, quite frankly speaking, there are no winners here. Everything is a beautiful tool in itself. It's the situation that demands the right tool there. Uh, so, orchestration tools, there are other things that we've not listed. There are also PaaS services like OpenShift and all that can be used for your deployments, for your deployment of microservices, for your deployment of containers. Just that they're not mentioned here because they're not the majority stakeholders or the shareholders in the market. I think many projects or many of our clients have chosen one of these tools. Uh, so that's what is listed here. Similarly, with containerization, we typically use Docker containers uh, and we deploy them using Kubernetes. and also manage or Amazon ECS, and also store the containers on Elastic Cloud Registry or Azure Container Registry. Sorry, ECR is Elastic Container Registry, and Azure Container Registry, ECS or App Service. So there are many ways of managing your containers. Again, what is listed here is a limited set, but these are what we prescribe generally to our clients. And with respect to configuration management, Ansible is the most versatile tool. It is a tool that does not have to rely on a client being inside the VM or the container to be able to deploy and configure an application, right? Whereas Chef and Puppet relies on, I mean, they are both a master slave sort of idea, where you need a slave inside the machine for you to be able to configure that machine. So Ansible has sort of gained grounds in that aspect. You don't need Ansible is sort of what we prescribe to our clients always. Uh, Moving forward to the multi-cloud deployment and infrastructure as cloud. Uh, we always have had ARM and CloudFormation templates, but Terraform has sort of taken over for you to be able to build one template that can work with all clouds. So we, as lately, we've started recommending Terraform to all of our clients. ARM and CloudFormation templates are still being written for clients who are very sure that they are only going to be in that platform and are never going to move to another cloud platform. So that's another set of tools that you'd need for you to be able to provision machines. Uh, Cloud, again, all three clouds provide a lot of features for you to deploy microservices containers. There's no winner here again. You can pick any of those. They all have plenty of options for you to be successful. Uh, Again, once you've deployed, there is always a need for you to log and do search of your logs, do analytics from it, make sure your performance is fine, look at exceptions and all that. And generally, we recommend Elk and Datadog for that. These two are pretty common tools that many of our clients are using. So it's quite easy to deploy and manage, and easy to link it up with your existing applications and existing your infrastructure, right? So at a very high level, these are the tools and services that you would need for you to be able to deploy a microservices architecture on the cloud. Uh, Moving forward, I would like to present a few experiences that we've had in the past building microservices for clients for specific needs in various business domains. So I have a few such experiences that I'd like to share. The first one is for a leading education, publishing, and assessment services provider in the US. Uh, this project, apart from deployment of applications in a microservices fashion, it was also a migration project. They had everything deployed on their on-prem servers. They had everything deployed on a couple of data centers in the US, and they wanted everything to be moved to the cloud. And that's where we started working with them. We enabled the migration as well. We came up with a program called Trio Migration, where we moved three of their uh, applications onto the cloud that involved data migration. Their data center, the application hosting itself was moved, and then the management of it, everything, all the DevOps parts, the other control, everything was moved on to the cloud. Right. As you can see in the picture, we used Kubernetes that was managing a swarm of Docker containers. And of course, the whole deployment was managed by Jenkins. The entire workflow or the orchestration was handled by Jenkins. And all servers had blue-green deployments. There were 6 different environments. There was a dev environment, a test environment, a pre-production environment, a certification environment, a performance environment, and then a production environment. Right. So in each of these environments, the number of containers that were deployed were, I mean, it varied depending on the load and scale. Uh, so typically, the Jenkins triggers the process as soon as a developer commits code. We pull the code, build it, store it into Nexus. Nexus is our artifact repository here. And then we also build images and store it on ECR. Uh, the ECR then Kubernetes will automatically pull the latest images from there and publish it to the containers, or create new containers, killing the old ones, slowly replace them. While all the configurations are managed in AWS Secrets Manager and param store, and the configurations were administered using confd, right? So each container had its own configuration being pulled from confd and updated in their separate containers. Uh, Again, routing to the application happened through an ALB, which again routed its requests through the uh, EKS ingress, and somehow these things. There was always a blue-green deployment strategy for every service. So if something failed, we always had to route, and the ingress took care of routing between blue and green at runtime. Uh, so that's at a high level. And again, this application used RTS. All the data were migrated from their on-prem infrastructure to RDS, and all migrations were taken care of in a way that there was zero to very little downtime. Uh, at this stage, not just the RDS, it was also the queues. Every data storage required for it was, if all data of any form, queues, RDS or caching, everything was moved to the cloud, and the whole application relied on that layer of data storage. Right. Uh, and again, data from these containers were again pulled out. There were also CloudWatch services invoked, which monitored the VMs, while there were other services inside the containers that took the logs out, Logstash, which would move the logs to the elk stack. So there were always a way for people, developers or testers, to look at how the application is performing, what the exceptions are, and everything related to that application. So this was a very large migration, and in production, there are at least about 500 to 600 containers running at any given point of time. And it's all because it's all monitored and managed centrally. The application would scale automatically. There is a min and max limit set for everything, the VMs as well as the number of containers for each application. And this application in itself had we migrated 3 different applications. Each application had at least 20 different services. So there were some services that were common to to all 3 applications, so which were deployed separately, and each of these applications had other specific services, which were all deployed together. And of course, these containers were distributed onto different VMs, so that even if an entire VM goes down, we still had the service up and running in some form or fashion. Uh, this is an example of how we microservices based application where everything is automated. So today, nothing changes except for upgrades. And as soon as upgrades, or as soon as a developer does code changes, that is automatically built into at binaries and also as images, automatically pushed to dev environments. And once dev testing, again, it runs several automated tests. There are automated test scripts, unit tests. There are also other performance testing scripts. So all of these are run on a dev instance. And once that passes successfully, then things are promoted to the next stage based on approvals and based on the right privileges, right? Uh, so this is sort of an idea of how, or one idea of how a microservices architecture can be deployed. Uh, Again, there were a lot of benefits that they got from it because this application relied on a lot of content, and they had to upgrade the application quite often. Because they were moved into containers, upgrades became very seamless. Things were easy, and it just became very simple for anyone to do an upgrade. Similarly, since the applications were monitored, they were automatically scaled and automatically healed. Even if a machine goes down for various reasons, overloaded or just for any small reason, even if it's uh, a very simple reason, we still, if the container becomes unhealthy or if the machine becomes unhealthy, they are automatically removed and a new machine replaces it. So this self-healing architecture helps them in a lot of ways. So they don't have to go into the system to change anything, or there is very little manual work in terms of management, right? So that's one of our very recent experience. And I'll move on to another case where we built something similar. We built an ecosystem of services, which again, the ecosystem had applications written in .NET, Java. There were a variety of uh, uh, code programming languages, and the tech stack itself changed with every application. So the entire application or the entire suite of applications or services were all deployed on Azure. Each of these applications again had multiple components. Some of them were separated into uh, a UI layer and a service layer. Some of them had more than just a single service layer. Some of them had multiple service layers. So this example is more or less an example of a suite of applications. Each of these applications had their own microservices architecture. So in a way that these applications, each of them are microservices, and they all of them worked in a multi-tenant fashion. All of them relied on a central identity and multi-tenancy service, which provided authentication, authorization, self-service of tenants, users, billing, metadata management at a tenant level, uh, auditing, logging, and so many features. All of them siloed based on tenancy, right? Each of these applications again had their own environments, dev, test, UAT, and prod. Uh, we, as the developers of these applications, we made it mandatory that we would have access only to dev, test, and UAT. Beyond that, even in UAT, we had very limited access. Production, of course, we enforced the customer that they should take complete control of it and never expose anything to us. Again, this whole application or this whole product was built for a industry leading consulting firm. Many of these were consulting applications where it gives engaging experiences for their customers. They could just sign in, or their companies could just sign up and then let their users sign in. Uh, and their users could simply use the services in a variety of ways: tax, financial consulting, and so on. Right. Uh, this example was a very neat example of how a particular CI/CD setup needs to be done. Uh, the flow of it and who has control of it. So, for example, an application, for it to move from dev to test to UAT, there were approvals required at every stage, and only specific people had that approval. And things were controlled in a very nice way. Everything was on the cloud, right? With respect to benefits, again, it was a multi-tenant system, so they were able to onboard multiple clients onto it, make more money from it. Reduced production defects because it was going through three different stages, and everything had proper approval and things. And because they were containers deployed on app services on Azure, it was again easy for you to switch and revert and restore and everything. Uh, so there were very little production defects. Things worked perfectly well, and of course, improves efficiency and traceability. Having talked about all of our experiences, I'm pretty sure there are a lot of questions on how we do things, how or what our recommendations are, how microservices architectures are handled by us, maintained by us, developed by us. So I'll let it for a QA session. I'll let it open for a QA session. And thanks for listening.